Good morning everyone. Welcome back in our district class 9. Today I am going to start exercise 6.3. Before starting this exercise, I am going to give you two proofs. First, angle sum property of triangle. Second, extreme angle property of triangle. Now move to first angle sum property. Angle sum property of triangle. How can we prove angle sum property of triangle? It is one of the theorem which is given in your book, but it is the most important part which you have to learn before starting the exercise. So here we have a triangle. Firstly, what is angle sum property? What is the statement? The sum of all interior angle of a triangle is 180 degree. We have to prove this statement. Okay, for having a proof, we have to firstly draw a figure, which I have told you. Every geometrical sum needs a figure. So here we have a triangle. So we write the same statement. Firstly, given. What is given? ABC is a triangle. First statement is that what we have to prove? To prove what we need to do, we need to prove angle A plus angle B plus angle C equal to 180. Okay, students. So we need to do a construction step. So we write here construction step. What construction we are going to do? We draw a line which passing through A and which is parallel to BC. So here we can write PQ. Okay, students. So draw PQ parallel to BC, which passing through A. Okay, let's start proof. How can we prove that? So here we know that we have a parallel line, which we mentioned that PQ parallel to BC. If PQ parallel to BC, you know that this angle 1 and this angle 2 form a special thing which is known as alternate interior. So if lines are parallel, then we can write angle 1 equal to angle 2. Why? Alternate interior angles. If you mention a parallel line, then you can use this property. After that, we can say that this angle 3 is equal to this angle 4. How those angles are equal? Because we have already wrote that PQ parallel to BC, so we can write angle 3 equal to angle 4 with the same alternate interior and property. After that, we have seen there are three angles that forms 180 degree or a straight line. So here we can say angle, or we can write the statement now. We start the statement from the word now. Angle 1 plus angle A plus angle 3 is equal to 180. Now we cannot able to write here linear pair because it is not a pair, it is more than that. We can write a straight line. Straight line. So here angle A is equal to angle 2 and this angle 2 is regarded as angle B. We can change that. That angle A is itself angle A, and here we can see that angle 3 which we are talking about is equal to angle 4 and angle 4 named as C. Here we can write angle C and all of them will be together 180. Now this one is our proof, but it is not arranged. So we have to arrange in this manner. We can write angle A plus angle B plus angle C is equal to 180, and this is our proof which we want to prove. How can we prove that? Firstly, I want to make it revise again. Firstly, we make a triangle and then we name it as ABC. After that, we draw a parallel line which is parallel to the base BC. This one is parallel to this whole line PQ. So here I have written that PQ parallel to BC. Then we can do that angle 1 equal to angle 2, alternate, and angle 3 equal to angle 4, which is again alternating triangle. Now we can add these three angles with the property straight line. Now here angle 1 denotes angle 2 and angle 2 is equal to angle B. And angle A itself angle A, and angle 3 is equal to angle 4 and angle 4 is denoted as angle C. So here B, A and C comes together 180. Here we can rearrange that and write the actual thing. So here we have done our first theorem. This is a theorem, the angle sum property theorem, and the statement. You have to learn a statement also, because by the statement sum will ask, or directly angle sum property of triangle we need to prove as like. Okay students, now move to our other proof. Okay. Now here we are going to prove our next theorem, which is extriangle property. Now what is extriangle property? It's very simple. It's as simple as angle sum property. Okay, so firstly we have to write the statement. For the statement we have required, if one side of triangle is produced then exterior angle so formed is equal to sum of its two interior opposite angles. What the statement? If one side of triangle is produced, then exterior angle so formed is equal to sum of its two interior opposite angles. So here we have a figure, because without figure it is not possible to show anything in this geometry. So this one is a figure of triangle ABC. One of the sides are produced. So here I am going to produce this BC to an element B. So here an angle is so formed. This is known as our exterior angle. Okay. So here we are going to write firstly given triangle ABC, which we have to produce. BC is produced to D. It means we produce a line which is in direction of BC. If we write CB, then C to B. But when we write CB, BC, then it is going to B to C. So B to C to D. So when we produce BC to D, BC को D तक produce किया गया. Then we have an exterior angle which is so formed in the form of given. So proof. To prove what we have to prove. So we have to prove that what angle A plus angle B is equal to angle ACT. So here no need of construction step, directly we can start. So we can say that angle A, angle B and angle C makes together 180. First we write triangle ABC. Basically in triangle ABC, angle A plus angle B plus angle C is equal to 180. By which property? Angle sum property of triangle. Okay students, why we write angle sum property of triangle? Because triangle must be mentioned. Because after this chapter in class 8, not class 8, in chapter 8 we have again angle sum property of quadrilateral. So we write angle sum property of triangle. After that we can say that angle C plus angle ACD is equal to 180 by meaning here. Which two angles? These one. These one form 180 degree. Here it is of equation first, here it is of equation second. Now we can see that both equations have similar answer. So we can equate them by exam first. From equation first and second, we have write this statement, but which exam we have related here? We have related exam first exam are used here. So angle A plus angle B plus angle C equal to angle C plus angle ACB. Now this is cut from that. So here we have angle A plus angle B equal to angle ACB. This one we have proved. So here I have done the second proof. This is extra angle property. Now we have two proofs. First angle sum property, extra angle property, and one basic parallel theory, which is parallel transversal, and three more theory. One is linear pair, second is vertically opposite and adjacent. So all these form of concept, and all the concept we are going to use in our upcoming exercise 6.3. So here I am going to start exercise 6.3. Now the first sum of exercise. The first sum is made in a triangle, which name is PQR, I think so. Yeah, it is PQR. One of all is produced in the manner of this, and second QP is produced as. Here we have produced two of the side of the triangle. So here the angle which is given here is 135, and here we have given angle 110. So which angle is given? Angle SPR is equal to 135 degree. Angle PQT is equal to 110 degree. These all are given. What we need to prove? We need to prove that angle PRQ. Find, not prove, find. Which angle? Angle PRQ. Solution. PRQ. So firstly we have to know about this angle or this angle. Okay. Firstly we have to find this one. So angle QPR plus angle SPR is equal to 180 by linear pair. So QPR it is not given, but SPR is 135 at 180. Now transpose this to other hand. Angle QPR is equal to 180 minus 135. What remain here? So here we have 5. 4 minus 3. Sorry, 7 minus 3, 4. 45. Angle QPR. So it is 45. Okay, students, this angle is 45. Now, this angle and this angle forms extreme angle. Now, in using extreme or entry angle, we have to mention triangle first. Triangle PQR. In triangle PQR, angle QPR plus angle PRQ make together angle PQT. So angle QPR is 45. This one is angle PRQ, which we have to find. Now here it is 110. Now transpose to other hand. So it will 110 minus 45. So it is 65. So angle PRQ is equal to 65. So this is the way. In this manner we have to do some number first. Now note down the sum. After that sum, second is very important. So after this sum I am going to solve question number second. I am going to rub it. You can take a screenshot, wait the video, firstly pause the video and take a screenshot. It will be helpful for noting the sums. I am not waiting anybody for note down the sum. Now the second sum, it is very important sum and it has one more concept which is known as bisector of the angles. So here we have a triangle. I want to make this figure more larger than the previous one. X, Y and Z, and OY and OZ, these are the bisectors. So what are the bisectors? First we know about, but I am giving you information. Firstly I want to form the figure. This whole angle X is equal to 62, angle Y equal to 54. Which angle we have to find? We have to find Y is Z, but before that I want to write OY and OZ are angle bisector. And of which angles? Angle bisector of angle Y and angle Z. Respectively. Respectively is in order. Which order those bisectors given? On that order the angle will be recognized. Okay. Now we have to find what we have to find. We have to find angle YOZ. YOZ. So firstly, I want to tell you about bisector. Bisector means a line which bisect an angle in two equal parts is known as the bisector of angle. And if a line bisect a line segment into equal parts, it's known as line bisector. So there are two types of bisector. First, angle bisector, which divides an angle in two equal parts, and second is a line bisector, which divides a line into equal parts. Okay students, so here first of all, angle X plus angle Y plus angle Z is equal to 180. By which property? Angle sum property. One of them is 62, second of them is 54. We have to find angle Z is equal to 180. Then angle Z is equal to 180 minus these two make together 4 or 6, 6 or 5, 11, 116. So what is remain? Remain 64 degree. Okay student, this one is remain 64 degree. Now what we have to do? Firstly we do the bisector of the given angles, then the rest of the sum. And dividing this board into parts. On that part we are going to do the rest of the sum. So angle OYZ, it is half of angle Y because OY bisect angle. So angle OYZ is equal to half of 54, that is 27. So angle OZY, we are getting OZY, this one is 27. I have found it right. You have to find this one also. On the angle OZY is equal to half of angle ZY because OZ bisect angle Z. So this one is angle OZY is equal to half of what it is? It is whole 64. So it remains 32 degree. Now after finding these two, we have to recognize or we have to apply angle sum property in YOZ. In triangle YOZ, angle YOZ plus angle YZ plus angle OZY make together 180 and angle sum property. Here I am writing the reason. Now put which value we have known. Firstly we have to put here YOZ we have to find, so you need to put that. This is 27 and this is 32 makes together 180. So angle YOZ is equal to 180 minus 3 or 2 and 7 and 3 or 5, 59. So here it is 121. It is angle YOZ. This one is our final answer. Okay student, I think you understood about the sum. So moving to the next sum. Now I am going to solve question number 5 directly, because question number 3 and question number 4, it is very easy in order. You can solve that sums very easily. So I am going to solve question number 5. Okay students. So in question number 5 you have to make the figure. Okay students. So I am going to make the figure of question number 5. Now in question number 5 I am going to draw the figure. So this one is P, Q, R, S and T. So here the first angle, which is not given, and B, this one may be X and this one may be Y, and 28 and 65. Okay student, what it is given? Firstly, PQ perpendicular to PS. PQ perpendicular to PS. Where is it? At the point of P. After that, angle SQR. Angle SQR is equal to 28 degree, and angle QRT. Angle QRT is equal to 65 degree. Okay. We have to find X and Y. Find X and Y. It may be very anywhere we can write the X and Y. Here I have not the book, so I give you the from the written summation. So it may be vary. So if it is vary, then you can change that. Now solution. First of all, here, and one more thing is missing here. PQ parallel to ST. It is most important. So PQ is parallel to ST. So this angle O and that angle form Z. So we can say that these forms alternate interior. First we write parallel to Z, PQ parallel to ST. So angle PQR equal to angle QRT. Alternate interior angles. So PQ has two parts. PQR X plus 28, and this one is our 65. X is equal to 65 minus 28. 7. Here it is 5 to 37. So X is equal to 37. Okay students. Maybe here Y is written, so if Y is written, so place name and it as Y. If X is written, so there is no problem. Okay, so it is 37. After that, we have to mention this triangle. In triangle PQS, angle P plus X plus Y form together 90. Here we know that this property we have used A square of triangle. Now after that, P is 90, X is as usual 37 we have found it, and Y is equal to 180. So Y is equal to 180 minus 127. So 53 is remaining. This one is going our Y. So here we have done X and Y in this figure. Here alternate interior angle by the parallel concept, and angle sum property is used. So you can understand this sum very easily. There is no problem. Here we have most important sum number 6. This is the proof, and in the manner of proof we have to learn this sum. This one is the most important sum. Any teacher can ask this sum frequently. So learn this sum very carefully. Okay student, now move to question number 6. Now in question number 6, here we have triangle PQR. What? PQR, and one of its triangle PRX. But this triangle is inverted. Or join other triangle, that is QTR. So we can write triangle PQR and triangle QPR as what? That TQ and PR. QT or TQ, whatever you can write. QT and QR, that TQ and PR are bisector of angle PQR and angle PRS. What we need to prove? What we need to prove? We need to prove angle QPR is equal to half of angle QPR. How can we prove that? So, proof. How can we prove that? First of all, we are going to take triangle PQR in triangle PQR. Now see it properly. In triangle PQR, angle PQR plus angle QTR makes together angle TRS. First time I am going to write this property. This one is external property. TQR and QTR, this angle and that angle form together the given angle TRS by exterior angle property. Okay student, I think you understand which property I have used. Now in triangle PQR. Again exterior angle property. This one and that. Angle PQR plus angle QPR form together angle TRS. Again the same property, exterior angle property. I forget to mention the first one have to refer as the question number first. One thing must be equal in RHS or LHS. So here TR is given and here PR is given. But when we divide this PRS by 2, this PRS by 2, it will become TRS. So divide by 2. Divide by 2 on both sides. After dividing by 2, it may be equal? Yeah, it will be equal. By which property? By the axiom number 6 or 7. I think 7. Things which are half of the same thing are equal to one another. So after doing half, it will be equal. So angle PQR, after doing half, PQR is written as TQR. So angle PQR. And QPR has no bisector, so you have to write QPR upon 2 because it will not become equal. But angle PRS, when we do it divide by 2, it will become TRS. Angle TRS. So we can write after doing half these. By which property we have written that? So we have to mention that PQ and PR, PQ and PR are bisector, angles bisector of angle Q and angle PRS. That's why we can write the equal things together. After that, this one become TRS and now this one is also become TRS. So mention it as equation number 2nd. Now from equation first and second, here I am going to use axiom number first. Things which are equal to the same thing are equal to one another. This side is TRS and that side is also TRS. So we can make it equal as like TQR plus angle QTR equal to PQR plus angle QPR upon 2. Angle QPR upon 2. So TQR is cancelled by TQR. Here we have left angle QTR equal to half of angle QPR. So here I have done question number 6. This is a proof. I am going to revise it again. First of all, in triangle PQR and one another triangle PQR is angled with that, means combined. Both have actually angle. The first angle is PRS and second one will be TRS. Here QT and TR are bisector of angle this Q and angle this exterior R. We have to prove angle QTR is equal to half of angle QPR. So in triangle TQR, firstly we have to take in the smaller triangle, which we easily prove by extending property. TQR and QTR equal to TRS, extending property. Now move to triangle PQR. Here in triangle PQR, two parts. PQR, here it is PQR plus QPR. Here it is QPR. Bring together PRS. So we have to manage PRS as like treat that PRS, it will become TRS. So here I am going to divide by 2 on both sides. That PRS become half of PRS become TRS. Here half of PRS become TRS. Half of PQR become PQR. Here it is half of PQR become TQR. It is written, but it is not going to be half because QPR is an angle. There is not half situation will be possible. So we write that as in fraction form. Now both equations TRS are equal, so we can manage to form the LHS of both parts are equal. By which property? By the exam number first. Things which are equal to the same thing. So here things which are equal to the same thing are equal to one another. So we make it equal. So TQR is cancelled by TQR. What remains? QTR is equal to half of QT. Here I have done exercise 6.3 as well as our chapter is finished. In this chapter we have done 2 theorems and 3 of more than 3 properties. All the properties and theorem will use in our next chapter 7, congruency of triangles or triangles, because most of the properties are used in triangle. Okay students, so we will meet very soon in chapter number 7. Okay, take care and goodbye.